Part C of Standard 9 asks to write an equation that can be used to find the value of h, the variable h, such that the vertical line x equals h divides the region R into two regions of equal area. And you don't have to solve this equation, we just have to write it. So I wrote several different possibilities here, but essentially we use the same formula for using the integral to find the area between a function and the x-axis as we did in part B. We just write one integral from 0 to h, and then one integral from h to 4. And so you can either set those two integrals for area together and say they're equal, and then solve for h using the antiderivative, or from the previous problem we solved and found that the area of the total region is 16 over 3. So 1/2 of that is going to be 8 over 3. So you can just use either one of these integrals, either 0 to h of root of x dx or h to 4 integral of root x dx, and set that equal to 8 over 3 and solve. And then for part D, it asks for us to write an equation using the given variable k. So it says write an equation that can be used to find the value of k such that the vertical line x equals k divides the region R into two regions such that when these two regions are revolved about the x-axis they generate solids with equal volumes. So I drew a short little diagram here so if you can imagine this here is the line x equals k. And so this is the first part of this region under this graph and between the x-axis, the one that I just traced. And if you revolve it around the x-axis, it'll be revolved all the way around this way and resemble somewhat of a cone shape. And so, and this area right here on the other side of x equals k, between the graph of root x and the x-axis, when revolved around the x-axis, will resemble somewhat of a cylinder shape, but not completely. But both of these solids, to find the volume, can be represented by the addition of the volume of infinitely small cylinders that I drew here. And so that can be represented by a summation or an integral. And so for both volume integral, what's going to be the integrand inside the integral is pi times the radius of the cylinder squared. And then dx is going to be the height. And so height times the area of the face is going to be volume. And so the radius of each cylinder is going to be root of x squared, or the y value of this function, as you can see here. And so your area of each cylinder is going to be pi times root of x squared, the area of the face of each cylinder, and then times dx is going to be the volume. So the integral of that from 0 to k and from k to 4 in this problem have to be equal, because it says both of these solids have to have an equal volume. So you can just set these two integrals equal to each other and then solve. And that's how you do part D.